The old way of thinking about wheelchairs is about to change. There is now hope for maximizing the comfort of the elderly and people with disabilities who spend long hours in wheelchairs. Dr. Hideyuki Hirose from Japan's Research Institute of the National Rehabilitation Center for Persons with Disabilities is discovering new ways to improve people's assistive equipment.
I'd like to study how to measure the sitting postures, because I'm joining the ISO members, and I'd like to change the ISO.
People who are forced to spend a majority of their time sitting in wheelchairs can be susceptible to pain, bed sores, and other unfortunate side effects. The poor posture many chairs enable can have several negative effects on a person's health, such as impaired breathing or swallowing. In the past, visual judgment was the only way to determine a wheelchair's fit for its user. However, the actual state and position of the pelvis and spine are not discernible to the eye, making it practically impossible to accurately judge whether the wheelchair really encourages the user to assume good posture. This is the main reason behind Dr. Hirose's ongoing efforts to establish new methods of quantifying best posture. Dr. Hirose has been active in presenting proposals for revising and improving the ISO standard regarding the quantitative measurement of a person's seated posture. He devised and published a method of measuring the inclination angles of the spine and other body parts of a person sitting in a wheelchair. To achieve this, he used a ferro arm. Since ISO standards stipulate that the user's posture should be measured using a wheelchair-based coordinate system, Dr. Hirose chose the ferro arm, a portable 3D measurement device that can capture detailed coordinate measurements. The measuring method with the ferro arm is quite simple. By merely touching the floor, the wheels and axle of the wheelchair, as well as different parts of the human body with the arm's measurement probe, the software produces corresponding coordinate values. Specifically, Dr. Hirose is using the ferro arm to calculate the inclination angles of the spine, pelvis, and other body parts from measured 3D coordinate data. The software then provides Dr. Hirose the coordinates to be imported into his program, where proper posture can then be calculated. Dr. Hirose chose the ferro arm because of its portability, range, and accuracy. The portability of the ferro arm is a huge advantage, as posture measurements for people with disabilities and the elderly can be conducted in hospitals and nursing homes, not in laboratories.
There is some reason to select a ferro, and one is to get a three-dimensional position. We have to measure the sitting postures in the hospital or nursing homes, and the ferro is a very portability to bring the many areas.
In the future, Dr. Hirose hopes that measurements will be made in the field at clinics and the like, and the resulting data will be accumulated into a database of medical information. He hopes that as huge amounts of posture data are collated, he will be able to shed new light on the relationship between posture and its negative effects for those confined to wheelchairs for long periods of time. Also, concrete numeric data will be available for identifying those postures that improve the breathing function, to help people eat more easily, and ultimately to extend their lifespan.